Morning. All right, so today we're working on lesson 4.8, and our topic is dividing using partial quotients. So this is going to be similar to multiplying using partial products, where we break up the number into smaller values and then add our partial quotients. So, unlock the problem. At camp, there are 5 players on each lacrosse team. If there are 125 people on lacrosse teams, how many teams are there? Underline what you're asked to find. Okay, right here. So, if there are 125 people on lacrosse teams, how many teams are there? Circle what we need to know. Well, we need to know that there's 125 people and there's 5 players on each team. What operation can you use to find the number of teams? Well, we're going to use division, right? Because we have a total amount, 125, and we need to share it in groups of 5. All right, so one way we can solve that problem is using partial quotients. And so in the partial quotient method of dividing, multiples of the divisor are subtracted from the dividend, and then the partial quotients are added together. So 125 divided by 5, it can also be written as 125 divided by 5. So we're going to write 125 divided by 5 like this. And step 1, start by subtracting a greater multiple, such as 10 times the divisor. For example, you know that you can make at least 10 teams of 5 players, right? Because 10 times 5 is 50, and 50 is less than 125. So we're going to do that, and then we're going to continue subtracting until the remaining number is less than the multiple 50. So let's start here. And so we're going to put 50 there. And so our divisor is 5, right? Okay. So 10 times 5 is 50. And when we subtract, we have 5. We have 75 left. Can I take away another set of 10 5s? Yeah, 10 times 5 is 50, which is less than 75. So I'm going to take away another 50, which would be 10 sets of 5. And I subtract and I hit 25. Well, now we can't take 10 away again, because 10 sets of 5 away again, because now 50 is greater than 25. So is there a factor 5 times something that gives me 25? Yeah, 5. Okay, so I can go 5 times 5 is 25, and that gives me 0. Okay, and then I'm going to add up the partial products, which gives me 25. So I could make 25 lacrosse teams. So what did we do after we were subtracting greater multiples, like 10 times the divisor? Well, we subtracted the smaller multiples, such as 5, 2, or 1 times the divisor, until the remaining number is less than the divisor. So we got down to here, 25, and we subtracted 5 multiples of 5, which gave us 25, and we subtracted until we had 0, which was less than the divisor. Okay, so 0 or less than the divisor. All right. So another way we could do this is to use rectangular models to record. And so Jared and Anna also found the number of teams using partial quotients. They recorded the partial quotients using rectangular models. They each still had 25 as the quotient. So let's see what they did. So we started with our total amount. So the whole rectangle is worth 125, and they're dividing both of them by 5. So in Jared's case, he said, okay, I'm going to start with 10 multiples of 5. And 10 times 5 is 50. And so 125, take away 50, gives me 75. So after step 1, he subtracted 50, leaving him 75. He then said, okay, so we have the 50 already. And he said, I can take away another 10 multiples of 5, which is 50. And so 75, take away 50, gives me 25. So you notice that the shaded areas are what's been taken away. Okay, the 25 is what still needs to be done. All right, so then he finally said, oh, well, I can take 5 multiples of 5 to get 25. All right, and 25 take away 25 is 0. And then he just added his 3 partial quotients, 10, 20, 25. All right, let's see what Anna did. So she still has the 125, and she's dividing by 5. She started with 20 multiples of 5. She said 20 times 5. Well, that's 100. That's less than 125. Let's start there. And so she subtracted 100 from 125, and that left her with 25. Okay, so she subtracted the 100 and leaving her 25. She then recognized that 5 times 5 is 25 with a remainder of 0. So she added 20 plus 5. Okay, so either way it works, right? Jared's method might be easier in the sense that the numbers are smaller, but Anna's may be more efficient in that it only took 2 steps. Okay, 3 steps versus 2 steps, but it really doesn't matter, does it? The bottom line is that we get to the quotient. All right, so number 1 on page 174. Lacrosse is played on a field 330 feet long. How many yards long is a lacrosse field? And it says 3 feet equals a yard. Okay, so we're going to divide using partial quotients. So first we're going to write our division problem. 330 divided by 3 as 330 divided by 3. And see, here we have, they want us to take away 100 sets of 3. What's 100 sets of 3? 100 times 3 is 300, right? Okay, so 30 take away nothing is 30. And then there's no hundreds left. All right, so we have 30 left. And 10 times what is 30? 3. So they took away another 10 multiples of 3 to get 30. And then 30 take away 30 is 0. So they took 100 multiples of 3 and 10 multiples of 3. So the field is 110 yards long. Okay, well that's not too bad, right? Okay. Divide using partial quotients. So we have 225 divided by 3. So can I take away multiples of 10? Sure, definitely. Can I take more than 10 multiples of 3? 10 multiples of 3 is 30. That's not very close to 200, is it? How about 20 multiples of 3? 20 multiples of 3 would be 60. I think I can still get closer. 40 sets of 3 is 120. 50 sets of 3 is 150. 60 sets of 3 is 180. 70 sets of 3 is 210. Well, let's say we wanted to start with 100 times 3. We can't do that, right? That's 300. That's too many. So we can't start with 100. So maybe we'll start with 50. 3 times 5 is 15, right? So 50 times 3 is 150. All right, let's subtract that. We get 5. All right, we get 75 left. So can I take 10 sets of 3 away? Sure. Okay, so let's do that. Now I'm down to 45. Can I take away another set of 30? Sure. 10 times 3. So that leaves me 30. Now I'm down to 15. Well, I can't take away 10 sets now. So how about 3 times what is 15? 5 times 3. And 5 times 3 is 15, so subtract. So we have to add 50, 10, 10, and 5. So 50, 60, 70, 5. So I could have started by going 70 times 3. And that would have given me 210. And then go multiply by 5 sets of 3 to finish it off. So it doesn't matter how you get there. I did wind up with 70 here. I just broke it up into just little smaller numbers. All right. And number 3, use the rectangular models to record partial products. So we have 428. I'm going to do this on another sheet of paper. So we have 428, and we're going to divide that by 4. Okay. So I recognize that I could multiply 4 times 100. That would be 400. So what is 428 take away 400? That leaves me 28. All right, so now, we have 400. Okay, I'm going to kind of shade that to show that I've subtracted that already, and now I'm left with 28. There's 2 options here. I know that 4 is a multiple of 28 is a multiple of 4. So I'm going to probably finish this. Could I break up the 28 into 20 and then 8? Yes, I could. But I'm going to go the basic math fact. So we said that we already subtracted that. And so now we're going to finish this off. 4 times 7 is 28. So 28 take away 28 is 0. So we have to add 100 plus 7. So we get 107. 428 divided by 4 is 107. All right, number 4. 198 divided by 9, and we need to use partial products. Well, I know I can take away 10 at least. So I'm going to go 10 times 9. And 10 times 9 is 90, right? That leaves me a remainder of 108. Okay, now if we have 108, can I still take away another 790? Sure I can. So 10 times 9 again, and that gives me 90 again. So 108 take away 90 is 18. Okay, 18. I can't take away 10 sets of 9, but 9 times 2 is 18. 9 times 2 is 18. 18 take away 18 is 0. My divisor is, what's left is 0, which is clearly less than the divisor. So what did we add? We have 10, 20, 22 sets of 9s equals 198. 259 divided by 7. Well, I know I can take 10 sets of 7 for sure. So I'm going to start there. And that leaves me 189. Well, I know I can take away another set of 10 sevens. And that leaves me 119. That's also more than 70. So I'm going to take away another set of 10 times 7. And now I'm down to 49. I can't take away 10 of those, but I do recognize that 7 times 7 is 49. So how many sets of 7 did we take? 10, 20, 37. 37 sets of 7 is 259. 864 divided by 8. Well, this time I know that 100 times 8 is 800. So I'm going to get as close as I can on that one. That one's fairly easy. And then I'm just going to use the basic math fact. 8 times 8 is 64. And so we're at 0. So all we have to do is add 100 plus 8. We get 108. 738 divided by 6. Again, I'm going to start with 100 sixes. 100 sixes is 600. And now we're left at 138. Well, I'm going to take away 10 sixes. I know I can do that. That leaves me 78. So I could have taken 20 sixes away. If you wanted to do 20 sixes, that would have been 120. So that's fine. You could have done that. And now I'm going to take another set of 10 sixes away. And now I'm down to 18. What times 6 is 18? 3. And that leaves me 0. So these are my partial quotients. 100, 10, 23. 123. All right, number 8. Use rectangular models to record the partial products. So we have our initial rectangle of 328. I'm going to divide by 2. So what do we want to start with? Well, I know that 2 times 100 is 200. I think I'm going to start there. So I'm going to be splitting the 328 into 200. And what's 328? Take away 200? 128. So far, I've used 100 sets of 2, and I'm left with 128. Well, how can we break up the 128? Well, I know that 2 times 50 is 100. That leaves me 28. So we would have 128, take away 100. 50 times 2 is 100. And I have a remainder of 28. Well, we can break up the 28. Right? We only have 28 left to divide. I'm going to break that into 20 and 8. Okay, so 2 times what? 2 times what is 20? 10. 10 times 2 is 20. And we have a remainder of 8 so far. Okay, and so we're going to finish one more time because 8 is bigger than the divisor 2. 200, 128. Again, the shaded areas mean I've subtracted it already, and this is my last step. So how many 2's does it take to get to 8? 4. And 8 take away 8 is 0. So we have to add 100, 50, 60, 4. 100 plus 64, 164. And number 9, 475 divide by 5. Well, I can't take 100 away because that would be 500, but it's pretty close to it. So how about 80? Because 8 times 5 is 40. So 85s would be 400. So let's do that. Could you start with something smaller? Sure. Five times what is 40? 8. So if we take the 400 and call it 40 tens, we would have 8. We would have 80 tens, right? Okay. Okay, so 80 times 5 is 400, taken from 475. That leaves us 75 to split in from, to be taken from 75. So how many 5s can we take away from 75? Well, I know I can take 50 away, so let's do that. So what is 75? Take away 50, 25. 25 is left. So 5 times what is 50? 10. All right, so we've now taken away 450 of the 475. We have 25 left. The shaded areas means I've already taken it away, and this is the last step. 25 divided by 5, 5, right? 25, take away 25 is 0. So 80 plus 10 is 90, 95. Okay, remember the top is our partial products. 80, 10, and 5. So 95. Number 10, 219 divided by 3. 219 divided by 3. So it can't be 100, because that would be 100 times 3 would be 300. I'm going to start with 50. I'm going to take away 50 sets of 3. And 50 sets of 3 is 150. So we're going to go 219, take away 150. And that's going to leave me 69. Okay, now I'm going to break the 69. I'm going to take away 60 of it, because I know 3 times 20 is 60. So 69, take away 60, leaves me 9. All right, now I'm going to finish it off by how many 3s can I take from 9? I can take 3. I can take 3 3s from 9. And 9 take away 9 is 0. So our partial products are 50 plus 20 plus 3. 50 and 20 is 70, and 3 more is 73. Number 11, 488 divided by 4. 488 divided by 4. Well, I want to take away 100 right off the, I want to take away 100 fours, or 400 away from the 488. 100 times 4 is 400. So 488, take away 400, leaves me 88. Now, how many 4s can I take from 88? I know I can take at least 10. That's 40. Can I take away 20? Yes, that would be 80. So let's break that into 80 and 8. 4 times what is 80? 20. So we have 88. Take away 80. We're down to 8. Okay, so our last step, how many 4s can you take from 8? 2. 4 times 2 is 8. 8 take away 8, 0. So our partial products are 100 plus 20 plus 2. 122. All right, number 12. What is the least number you can divide by 5 to get a 3-digit number? Well, the smallest 3-digit number is 100, right? But I have to divide by 5. So in order to subtract multiples of 5 to get a 3-digit number, this would have to be 500. 500 divided by 5 is 100, right? So the smallest number has to be 500. The smallest three-digit number is 100. So to get a three-digit quotient, you would have to have 5 sets of 100 or 500. All right, 176. Okay, use the table for 13 through 15. So let's look at the table first. Rob's sports cards collection. And he has baseball cards, basketball cards, football cards, and hockey cards. In baseball, he has 248 baseball cards, has 189 basketball cards, 96 football cards, and 64 hockey cards. All right, so he wants to put 8 baseball cards on each page in an album. How many pages will he fill? So our problem is 248 baseball cards. And he wants to put 8 of those cards on a page. So 248 divided by 8. So let's take away 10 multiples of 8, which is 80. We have 168. I can take away another set of 80, right? And that leaves me 88. I can take away one more set of 10 eighths. And that leaves me 8. How many eighths does it take to get from 8? 1. One set of 8 is 8. 0. So we have to add our partial products, 10, 20, 31. He needs 31 pages. $14. Rob filled 9 plastic boxes with basketball cards with the same number of cards in each box. Okay. 9 plastic boxes with basketball cards. How many cards did he put in each box? Okay, so basketball cards. So he has 189 divided by 9. So we're going to rewrite that as 189 divided by 9. Well, I know I can take at least 10 multiples of 9 away because that's 90. And that's going to leave me 99. Well, I can take another set of 10 nines away because 90 is less than 9, and that leaves me 9. I only need one set of 9 to get to 0. So add up our partial products, 10, 20, 21 cards per box. Okay. 15. Rob filled 3 fewer plastic boxes with football cards than basketball cards. He filled 9 boxes with basketball cards. How many boxes did he fill with football cards? How many cards were in each box? Okay, so there's 2 questions there, right? So 9, take away 3. So he filled 6 boxes with football cards. 6 boxes of football cards. And his football cards were 96. So 96 divide by 6. Well, I know I can take 10 sixes away. That leaves me 36. Well, how many 6s can I take away from 36? 6. Leaves me 0. So 10 plus 6, 16. 16 cards per box. 16. Marshall can buy 5 t-shirts for $60. If each shirt costs the same amount, what is the cost of 4 shirts? 5 t-shirts for $60. What is the cost of 4 t-shirts? So on this one, we need to figure out the cost of just 1 t-shirt first. So we're going to go 60 divide by 5. That'll tell me how much 1 shirt costs. And I know I can take 10 sets of 5 away. And so that would leave me 5. I know that 2 times 5 is 10. So each shirt costs $12. So how much would 4 t-shirts cost? So 12 times 4. 4 sets of 2 ones is 8 ones. 4 sets of 110 is 4. So $48 for 4 t-shirts. And 17. Use partial quotients. Fill in these blanks. So they went 80 times 5. 5 times 8 is 40. So 400. They subtracted, leaving them 85. 10 times 5 was 50. Subtract, they're left with 35. 7 times 5 is 35, leaving them 0. So 80 and 10 is 90, and 90 plus 7 is 97. Oh, I didn't see this box here. That makes more sense. 80, 10, 7 is 97. Okay. All right, so that's it for lesson 4.8. Our next lesson will be modeling division with regrouping. So kind of the standard way people would use division. So until then, may the numbers always be in your favor.